Have you ever needed to add a layer of control to an object without changing its code? Maybe you need to check permissions, log requests, or cache results to save time. How do you do that cleanly? The answer is a powerful design tool, the proxy pattern. First, we have the client, which needs a task performed. It will communicate with the proxy, which acts as an intermediary. The proxy, in turn, manages access to the real subject, the object that contains the core logic and does the actual work. Crucially, both the proxy and the real subject adhere to the same subject interface. This shared interface acts as a contract, ensuring the client can interact with the proxy just as it would with the real subject, without needing to know the difference. Now, let's look at our first scenario, using a proxy for protection and access control. The proxy intercepts this call. Before doing anything else, it can perform preliminary actions. Here, it runs a check permission function. This is the protection aspect of the proxy, acting as a gatekeeper to the real subject. Once the permission check is successful, the proxy delegates the request by calling the same method on the real subject. The real subject executes the task and returns the result back to the proxy. Finally, the proxy passes the result back to the client. From the client's perspective, the operation was seamless. It was completely unaware of the security check that happened in the background. Let's explore another powerful use for the proxy pattern, using the same core components: the client, the proxy, the real subject, and their shared subject interface. In this scenario, we'll see how a proxy can be used to cache results and improve performance. As before, the client sends a request, and the proxy first performs its gatekeeping duty with an access control check. Next, the proxy does something new. It checks its internal cache. It's looking to see if it has already computed the result for this exact request. On this first run, the cache is empty. It's a cache miss. Therefore, the proxy must forward the request to the real subject, which might be a slow or resource-intensive operation. The real subject processes the request and returns the raw result. Now, before returning the result to the client, the smart proxy saves it in its cache for future use. The client then receives the final result, completely unaware of the caching logic that just occurred. But what happens when the client makes the exact same request a second time? The request hits the proxy, which performs its access control and cache check as before. But this time, it's a cache hit. The proxy finds the result in its cache. It immediately returns the cached result directly to the client. Notice how the real subject was never contacted. This avoids the expensive operation entirely, saving time and system resources. So as we've seen, the proxy pattern is an incredibly versatile tool. We've explored how a protection proxy can enforce access rules, and how a caching proxy can significantly boost performance. The key takeaway is that a proxy stands between the client and the real object to control access and add responsibilities, all while remaining completely transparent to the client. This powerful separation of concerns makes your code more modular, secure, and efficient. Thank you for watching, and I hope this gives you a clear understanding of how and when to use the proxy pattern in your own projects.